All right, we were in the middle of a section on this one where we inadvertently got cut off, so I'm going to finish up that section of verse. This is measures of central tendency and variation. We were talking about normal distributions, and the problem that we were working on was one about IQ. So let me get to that screen for us. And the example that we had taken a look at and stopped on was the one on part C. How many students have an IQ between 70 and 145? We looked at a couple of ways to do this. One of the ways to do this, which is a really nice, clean way to do this, is to consider there being two pieces of this area defined. So this area in particular would be the 95% divided by 2. And then the other half of the area, or portion of the area, not half, but portion of the area that we referenced, would be over here out to 145, and this would be the 99.8% divided by 2. So if we add those two percentages together, then we end up with 97.4%. And then again, right, we're wanting to know the number of students, not just the percentage of them, so we can take that 97.4 over 100 and find out what that is out of 1,500 students. This would be 100x, and then we'd have 146100, and we end up finding out that we have 1,461 students. All right, we had one more topic in this section, and that was about percentiles. All right, so a percentile shows a person's score, value, whatever it is, relative to other scores or values. For example, if you had a score in the 90th percentile, then it would mean that approximately 90% of all other scores are lower than your score. So we see percentiles used in standardized testing all the time. We see them used in growth charts for children, like height, weight, head circumference. So if you're looking at being in the 50th percentile, it means that you are at the median, right? 50% of the scores are lower than yours. And likewise, that means then that 50 would be above where you are as well if you were looking at that particular one. All right, so we're going to do an example. And the example says the following. Junior was ranked 50th in his graduating class of 325 students. All right, so what does that mean? Well, it means that he had the 50th highest GPA. So there's 49 students ahead of him, and then 325 minus those 50, him included, would be below him. And then it says Liz was in the 75th percentile of the same graduating class. So again, that one is the percentile notation that we just referenced before in the notation on the previous slide, where it means that 75% of the students were at a value lower than she has, or GPA lower than her GPA. And the question we want to know is which student had the higher GPA when they graduated. All right, so we can do one of two things. We can either turn Junior's ranking in his class into a percentile, or we can turn Liz's percentile into a ranking. So first I'm going to turn Liz's percentile into a ranking, and that's actually enough, but I also want to show you that we could have done it the other way. So Liz is currently at the 75th percentile. So what we're going to do is we're going to, hang on, let me write this down. We're going to find out what that is in terms of her ranking. So we're going to take the 75th percentile and figure out of the 100th percentile how many students that means, in this case, are lower GPAs than she has. So this is x over, 325. All right, so we're going to have 100x, and then we're going to take 325 times the 75 to give us 24,375 divided by 100 gives me 243, and then it's 0.75. And we'll round, so this is approximately 244. So there are 244 students below Liz. So we need to know the number of students above her, though, to know her ranking. So we can take the 325 minus the 244, and we would say that Liz's ranking is that she is the 81st in ranking. So she's 81st. Junior, he was 50th. So the answer is actually that Junior has the higher GPA. And that's the answer to our question because Liz's ranking is 81. We could also find out, like I said, what Junior's percentile is. So if Junior is ranked 50th, then that means that there's 325 minus 50, or 275 students below Junior. So we could also find out, and I won't actually do the problem, we could find x over 100 to find his percentile of the 275 over 325. And if his percentile is higher than 75th percentile, which we know it will be because we've already done the problem the other direction, then that would mean that Junior has a higher GPA than Liz does.